Um, Hi, good afternoon. Welcome to the event hosted by Academy and Nestria. This is an event uh, on the topic Introduction to Machine Learning Operations, or otherwise also known as MLOps. Um, so, in this event, we will discuss at high level the various topics that go into building data analytical machine learning pipeline and the various uh, topics that we want to focus on if we want to get started building ML operation pipeline, right? So a quick guide um, for anyone who is looking to transition to the career of data science and machine learning and big data technologies. So this presentation will help in understanding what are the pre-requirements for transitioning your career into a data analytical field or a machine learning, artificial intelligence area of expertise. All right, so let's get started. All right, so the topics for discussion, we need first, let's understand why modern enterprises need to work with data, right? Now, machine learning operations or uh, artificial intelligence, deep learning involves with working with large, high-dimensional data sets. And in order to make powerful predictions, uh, so we need to understand why in today's day and age, modern enterprises need to work with data. Let's also talk about the topic big data and how it plays an important role in building data analytical machine learning pipelines. What is MLOps? We will discuss what is MLOps. We will also look at the high level architecture of building big data machine learning data solutions. We look at the technology system architecture, the principles and life cycle that goes into building big data analytical, using machine learning pipelines. And we look at some case studies as well. Okay. So the first question, before we jump into talking or discussing about machine learning and machine learning operations, um, first question we need to ask ourselves is what kind of data are we involved with? What data do we have collected which will help us to provide insights for business decision making and uh, revolutionize the way in the business operates with the help of fine tuning and building predictive models from existing raw data. Right. So data is an important factor for building pipelines. Uh, you know, uh, so millions of transactions and browsing clicks per day across products users. So what kind of data are collected? These are various examples of the kind of data that can be collected for performing analysis and building decision making operations with the help of machine learning or deep learning. Delivery tracking, reviews on multiple channels, website, social media, customer support, uh, different sources of data collection, support emails, call logs, ad clicks, and browsing data. Data is a mix of metrics, natural language text, logs, events, images, videos, etc. Right, so data that we can accumulate comes in various forms. It can come in the form of a text. It can be in a Excel, CSV file, a database file. The data can be in a form of a log, event, or videos, images, right? So there are different classification of data, and these are the various sources of data that can be collected and streamed to a source where you have all these various information of or observations of data being collected from various sources and stored in a bucket, preferably in a database storage on the cloud or on your local server. Right, so data plays a very important role in building analytical pipelines. So what is the data used for? So we understand what kind of data can be collected and sourced. Now, the next question is, what is the data used for, right? So the data which is collected from various sources, what can we do with the data? So example of data-driven enterprise, a large online retailer, example, Amazon, Myntra, user profile for better shopping experience, right? Now, all these large online retailer platforms provide rich experience for their customers and users for better shopping experience, operations efficiency metrics, improve customer support experience, support training, demand forecasting, right? So trying to make a prediction on what the product profit or loss or will look like in the near future, or estimating the company's net profit or loss or in the near future, right? Demand forecasting, product marketing. How can we influence the product to various customer database, right? Now we can perform target marketing, right? So specific products can be targeted to specific customers based on their previous search history experience of buying, similar products. Data is the only way to create competitive differentiators, retain customers, and ensure growth, right? So clearly, with the help of data, or many different um, real use cases can be applied, which will help the customers and the clients for better productivity and help in the overall strategy in the business growth, right? In terms of decision making and various other things that can be involved with growing your business. And data, help really helps, right? So data is the only way to create competitive differentiators, retain customers, and ensure growth. Now we have seen data has been growing at a very large, fast pace scale, right? Now data is being generated in large volumes in a short amount of time, right? So you can clearly see from nearly the transition from 2010 to a forecast to the year 2030, we see a trend where this data is only increasing, right? So we can forecast that by the year 2020, 2030, the distribution of unstructured data will be much higher than the distribution of structured data, right? So there are different kinds of data that is available. You have structured, semi-structured, unstructured. So you can clearly see that, by the year 2030, the volume of unstructured data is, 3 times the size of the structured data, right? So clearly 780 bytes of data unstructured data will be generated by the year 2030. So in order to, make sense of this data, which has been rapidly generated, over the years, the various features of these unstructured or structured data will help in making decisions with respect to the growth of the business, with respect to improving the performance of decision making, right? So clearly we can see the volume of data is only increasing over the time, right? And we can leverage the data for building predictive models, for reporting analysis, and overall with helping growing the strategy decision making of your business. So data volume growth clearly significantly rising in the next years. Variety of data sources. Now this is again falls back to big data and machine learning operations. Most machine learning operated pipelines involve processing and transforming large volumes of big data. And big data, comprises of data from different platforms or sources. Data can be acquired from sensor data, log data, data from the internet, data from social media, um, data from documents and archives, right? So big data can be sourced. Now, for a specific industry, let's say for finance, you can source the data from different platforms, which will really help in driving the decisions making. And this is just an overall picture of the variety of data sources that help or play a huge impact in the decision making. And um, the ML operations can be applied on various sources of data, and various sources of data combined, put together, forms the terminology of the big data, right? So big data technologies involve, sourcing data from various platforms, not just from social media or any web application, but from any other platforms, which will really help in driving the strategy of the business, right? The more quality data that you have enhances the model's predictive performance. So quality and quantity, play a role in driving the decisions. Okay, so variety of data sources. Now, all of these, discussions on data in terms of volume, variety, they are the initial stage of building a data analytical machine learning operated pipeline, right? So without data, you're not performing any transformation, pre-processing, or decision making without having the source of data, right? So the algorithms of machine learning and deep learning are applied to create a relationship between the features of your data set, right? So having data sourced from various endpoints collected and transformed into a structured format really enhances the overall performance of your model. Okay, so a quick run through of data classification. As I discussed earlier, there are different types of data. You have structured data in metrics, events that can be put into relational database management systems with a fixed schema. You have semi-structured data. So structured data is in the form of a relational database. Semi-structured data, XML, JSON data, where traditional RDBMS have support with varying efficiency, but needs new kind of NoSQL databases, right? So in the current technology market, you have SQL and NoSQL databases, where SQL language are applied to relational database management systems, and NoSQL is applied to no relational, database management system, right? So such no relational database management systems are examples like JSON data, XML data. They're semi-structured. And you also have a third type of classification of data, which is unstructured data. So new applications provide unstructured data, which could be natural language text and multimedia content, right? So images, text, comments, documents, all form examples of unstructured data, right? So we can clearly see, depending on the kind of problem that we're trying to solve, we can source the data from being it from a structured format, unstructured format, or a semi-structured format. So if your data is in the form of a semi-structured or unstructured, the transformation process to have it in a relatable data frame format, and the process of converting semi-structured and unstructured data to a relatable data frame format is an important step in building your machine learning pipeline. Right, so data usage patterns are higher demand now of analyzing unstructured data to gain insights. And in the recent times, the demand for analyzing unstructured and semi-structured data has, increased over the years. Examples of analysis of social media content for sentiment analysis, the way predominantly the usage of unstructured data is applied. Such example applications are analysis of social media content for sentiment analysis, analysis of unstructured text content by search engines on the web as well as within enterprises, analysis of support emails, calls, or customer satisfaction, NLP, conversational AI for answering user questions from backend data, right? Now, with the large variety and volume of big data, it really enhances the performance of your machine learning model, because you have the data sourced from various portals or platforms, be it in a form of unstructured or semi-structured form, and having the ability to transform and engineer these features of the data to bring it into an analytical report for analysis, or which will help the client in driving decisions for the business growth, right? Or when building chatbot, right? Some, the most popular chatbot in the current market is ChatGPT, which has been trained on large variety of data set. The data set being in an unstructured format of conversations, images, right? So the model has been trained on large variety of data being in unstructured or semi-structured or even structured form, right? So clearly we understand the data usage pattern where significantly the usage of data is higher in the current market, predominantly for text analysis, sentiment analysis, um, NLP, conversational AI, which are examples of chatbots, right? So for detecting whether your email or a message is a spam or not, right? So we receive tons of emails and messages from various sources, right? So the ability to identify and classify them as spam or not spam, credit for fraud detection. So all of these are example applications of where data comes into play, with which will help in making such predictive decisions of, for example, a spam or not spam. Okay, so I touched upon the various data sources. You have, structured data. You know, I'm not going to get into the details of structured data. I just have an example here, which will, make things simpler in understanding the various classification of data. Right. So data is transformed and stored as per predefined schema, traditionally stored in relational database management systems. You can perform your CERD operations. You have your integrity and properties of your database, which are your asset semantics, atomicity, consistency, isolation, durability, which are your properties to define a relational database management system. So an example, of a table within a database where it has various attributes or properties with its associated data type, right? Now, this is a structured database, an example, right? A structured table which has attributes defined and possibility of having multiple other different tables linked with, relationships. um, so a relational database management system contains multiple tables having various relationships, and how are the relationships created with the help of primary keys and foreign keys. Okay. Um, Again, an example of a structured data. Here's an example of unstructured data. So no explicit data or schema separation. So in the example of a structured data, the schema is predefined. In this in the case of a semi-structured data, the schema is not defined, right? So the data can come in any form. Um, Most likely look like it will look like a JavaScript object notation, JSON data, or XML data, which is another example of semi-structured data. And it could vary with the various kind of different attributes that comes with the data set, right? So no explicit data or schema separation models real life situations better because attributes for every record could be different, right? So it is not standard with the defined attributes spread across every element of the response in the JSON data, right? The variety of these attributes could differ. So easy to add new attributes. Okay. XML and JSON structures are examples of semi-structured data. Databases typically support flexible asset properties, especially consistency of replicas. Um, right. So in this example, clearly it is telling us that the chances of replicating values are okay in semi-structured data, but not okay with relational database management systems. Okay. So that's what this particular point tells us. Typically used by systems of engagement like social media, right? Example of semi-structured data. You have unstructured data as well. Now, it's very important before we jump into machine learning operations, we understand what kind of data we're dealing with, right? Because data plays a very important factor in driving decisions. Uh, yes. So unstructured data, as you can clearly see, an example of images, video, voice, text, emails, chats, comments, reviews, and blogs. All these are examples of unstructured data, right? So there is some structure that is typically extracted from the data depending on the use case. Image adjustments at pixel structure levels, face recognition from video, tagging of features extracted image or audio, annotation of text. So various example sources of unstructured data, right? So when we are feeding the data to a machine learning operated pipeline, it is important that we understand the kind of data that we're dealing in. It could be in an unstructured, semi-structured, structured format, and if it is, perform the appropriate transformation techniques to transform these unstructured and semi-structured to a structured form, right? Which will help the machine interpret the data without hassle. Okay, what can we do with the data, right? So data mining, association rule mining, market basket or affinity analysis. So association rule mining is creating a relationship between, for example, a data point or a product to the customer or the endpoint, right? So an example of association rule mining is, going back to the example of Amazon products being targeted to specific customers because they have a previous history of buying similar products, right? So that's an association rule where there's a relationship between the customer and the product, and the product is being recommended to the customer based on the customer's previous search history. So that's why data really helps in driving the decisions or targeting audience or customers in the market. Regression or predict dependent variables from independent variables. So regression helps in identifying the relationship between two attributes, okay, in your data set, or multiple attributes between your data set, right? So it helps predicting, dependent variable from independent variables. So collaborative filtering example, predicting user inference from a group of inferences. So various example use cases of what can we do with data. We can perform NLP, human to machine translation. Your chat GPT is a classic example of NLP. Text analytics, sentiment analysis, search, noisy text analytics, spell correction, speech to text. Right, so various applications of what we can do with data and how machine learning operation pipelines will help in analyzing and reporting these various use cases. Right, so at a large, let's define big data before we move on to machine learning ops. Right, so at a high level, big data is defined as three V's of big data. So the three V's of big data are volume, velocity, and variety. Right, volume is the sheer volume of data that we can acquire. For example, patient records to social media. Right, so health records, insurance, transactions, mobile sensors. So all these are examples of large volumes of data which is being generated on a day-to-day basis. Right. And the velocity of the data is, from modeling jobs to fraud detection. So the batch, near time, real time streaming are, the velocity of the data being generated, right? Volume is the size, velocity is the range, and variety is the range, and velocity is the speed, right? So velocity relates with the concept of how quickly are the data that can be generated on social media or any other platform, right? So data is generated at a frequency of milliseconds. So that falls with the concept of velocity of data, big data, right? And you can process the data in near time or real time, or you can process the data in batch operations as well. So different use cases of applying batch processing or real-time processing or near real-time processing, right? Which will satisfy the velocity of your big data. Then you have the variety. So variety, as we discussed, comes in various forms, right? Different kinds of attributes or features that can be part of your data set. You have structured, semi-structured, unstructured, kind of variety of different attributes that can persist in your data, right? So these three elements form the three volumes of big data. So it's essential that you identify the kind of problem or the data set that you want to work with, which industry you want to work with. Ask yourself whether you have the domain knowledge of or the business knowledge with working with that particular industry data. Do some research and understand the various attributes that persist, and understand what kind of processing power that you want to apply, depending on the kind of requirement, whether it's to perform batch-wise operation analyzing or perform real-time analysis, right? And the kind of variety of data that you're dealing with, right? So from all of these three are interlinked: velocity, variety, and volume, the three V's of big data. Okay, now we understand, data, plays a very important factor for building predictive models and monitoring and maintaining these predictive models, right? So this is where now machine learning operations comes into play. Now, a machine learning operations is a composition of machine learning development and operation, right? So data, as you can clearly see, the very first topic is your experiment, where you understand the kind of data that you're working with, which industry data are you working with, understand the various features of the data set. Now, is the data set in a structured, semi-structured, or unstructured format, right? So, for example, if you're working with a bunch of images or text, you want to understand how to acquire and transform these attributes into a machine readable language, right? Um, so data acquisition, business understanding, initial modeling, all falls under the headline experiment, right? So acquiring the right data, understanding the business of the data, and initial transformation of your data to a format which can be easily interpreted by the machine, right? So that's the idea with the experiment. So the second topic is develop. So here you're developing the model, the data which has been fed to the pipeline or to the the environment needs to be scaled and transformed or standardized before it can be applied with machine learning algorithms. The continuous integration and continuous development, the modeling plus testing plus continuous integration and continuous development, right? So these topics fall under development, where you model the data, you continuously test the model data on unseen attributes. As the data is as real-time data is being processed into the environment, it continuously updates its model, right? Because once the model is developed with an initial batch of data, it is tested on some unseen attributes. And in the next iteration, where real-time data is processed in batch to the trained model, the model is being trained with in a new set of unseen data, right? And you test the model's performance on the unseen data. You evaluate the model's performance with with various metrics. So that's continuous integration and continuous deployment. So continuous integration is going back to when new data is being trained, tested, and again integrated to the predictive model, and the predictive model is finally deployed to which will help in uh, making predictions on real-time unseen data and help the performance or help the reporting analysis for the client or the user who is working with your application, right? So that's a continuous integration, continuous deployment. The continuous deployment again, falls back to continuous integration. So when there's new batch data which is being trained and tested, let's say it improves the performance as compared to the previous model which was trained, and the new model which is trained now has a better predictive power and performance by evaluating its metrics in comparison to the previous model. So the new model will now be deployed for better user experience. Right, so this is a continuous integration, continuous deployment. Data is being processed in real time. Big data is processed in real time in batches through the model. Model trains. So the data which is being processed needs to be engineered, pre-processed, scaled, standardized before it can be trained with various algorithms in the modeling step. So once the training is done, it is tested to evaluate its performance with its various metrics, integrated and deployed. Right. In the next iteration, of when new batch of data comes in, it's again trained with the new batch of data, evaluate its performance, compare, and if you see that the performance has improved or decreased, you'll make relevant decisions to whether to deploy or not to deploy for the user experience. Right. And finally, the operation continuous delivery, right? So continuous deployment, continuous delivery, data feedback loop, system and model monitoring. So these are all, part of the MLOps, where you continuously deliver to the user, right, by comparing various models with the new data that has been fed to the model, as we discussed. Continuous feedback from the user experience to the maintenance team, and monitoring of your, model, so that at any given point in time, the model should not crash, and ensure that the system and the model performs at the highest level for best user experience, right? So all of these are various steps that can be integrated in a single environment pipeline. And most likely these environment pipelines can be Google Cloud Platform, or the services provided by Google Cloud, or the services provided by Amazon AWS, or by Microsoft Azure, right? So depending on the comfort level of a given cloud environment, you can perform the big data operations. You can perform, the machine learning operations, continuous integration, deployment, feedback, monitoring of your pipeline data can all be done on a single environment, be it Google Cloud, Amazon AWS, or Microsoft Azure. So life cycle of an ML project. So I did not talk about machine learning, right? So I'm assuming that some of you have an idea of what machine learning is, what is deep learning, what are the various subtopics that come under the umbrella of artificial intelligence and data science. So I'm just quickly going to touch upon the life cycle of an ML project. Scrape data. Now, data, as we discussed, can be collected in from different forms. You collect data. It could be structured, semi-structured, unstructured. So you ask yourself whether data quality can be improved. In that case, you go back to the question of how you can collect various sources of data and how you can really help in transforming those features to a format which can help the machine to interpret its attribute values and train the relationship between your independent and a target, right? So you clearly see the life cycle of ML project. You scrape the data, or you define the project, right? So the first step is to understand the kind of problem that you're dealing with, formulate a problem, formulate the project problem. What is the scope of your project? What is the business understanding of the data of the project? From where can you source the data? So ask yourself all these questions before you start diving into collecting the data and training the model, right? So spend good quality time on defining the scope of your project before you can start scraping and or collecting data from various sources, and then transforming and into a proper format which can be applied with ML techniques, right? So I can clearly see the life cycle of an ML project. Scope: collect data, define and collect data. The data is labeled. Consistency: check for the consistency of your data set, right? You train the model, training, error analysis, iterative improvements. You continuously perform cross-validation and parameter tuning techniques to improve the performance of your model, right? Can the data quality be improved? Yes. You go back to collecting more data, right? So if you notice that your model's performance is not up to the mark, right? So you ask yourself whether the data that you've collected is of high quality or not, right? So whether you can improve the quality of your data, right? So you go back to the question whether you can improve the quality. No. If you feel that, okay, the model's performance is up to the mark, which will help in driving business decisions, you can deploy the model in production, right? And in production, you can deploy, monitor, and maintain a system, maintaining the essence of your product, your deployed model on the given cloud environment falls back to the idea of continuous integration and continuous deployment, right? So this previous image. Okay, so this is another understanding of the life cycle of an ML project with its architecture, right? So on the underlying life cycle of the machine learning operations project, you have this architecture where you have, again, similar to the above image. This image talks about the kind of business cases that you're working with. What steps have you taken for engineering your attributes? What are the various machine learning operated algorithms that you're considering for your featured engineered features, production deployment, and production monitoring, right? So business understanding, use case identification, data understanding, feasible study. After you engineer these attributes, you prepare the data, you learn the machine learning algorithms, you train and test, you experiment with the model with cross-validation, hyperparameter tuning, evaluate its performance, and then just serve the data for production, right? Then you deploy, automate, operate, monitor, and optimize. So this is an entire end-to-end process of where you define your data, source your data from various portals, engineer, transform, train, scale, engineer, transform, train, evaluate, experiment, serve for production, and then deploy it for user experience. Then you automate the process, right? You focus on the maintenance and monitoring of the model's performance on the user end. You try to optimize it. And how do you optimize it is by feeding, more predictive performance data, right? So the model is continuously being improved with time because it's learning from more data that is being fed into the system, right? So the more data that we have, more data attributes that the model or the machine can learn from, better it will improve its overall predictive performance at the user end, right? So this life cycle or the underlying architecture of the life cycle, it makes it understandable at a very high level with what exactly goes in with the machine learning operations and what building pipelines on data and applying the appropriate algorithms, and finally you experiment and evaluate to deploy the model on the user experience end. Okay, so I hope this is clear. So what are the challenges that we face now? Clearly, the challenges that we work with big data and working with machine learning operations on various environments. So basic design considerations, distributed and parallel systems, reliability, availability, and consistency. Challenges: what data to keep and how for how long depends on the analysis use case. Choose the right technologies from many options, including open source, to build big data systems for the use case. Programming models, right? Most likely you can use your programming languages to work with sourcing your data to the model, right? You have MapReduce, Spark, which can be integrated with Python to perform your necessary engineering of the big data tool. All right, so a few other challenges that we want to consider: data privacy and governance. Cloud is a cost-effective way long term, but need to host big data outside your enterprise. Okay, so cloud is the way to go in the future for working with machine learning pipelines and big data operations. Think about your data privacy and governance. You don't want to misuse the data. Skill coordinated teams to build and maintain big data systems and machine learning pipelines. So what are your different types of MLOps big data solutions, right? So batch processing, building models, statistical aggregates, batch processing of data in batches you are training and evaluating and, deploying the model. Real-time processing as well, of big data in motion, right? So when you have big data in motion of real-time processing, the machine learning models help to process real-time data and continuously integrate and upgrade the model in the trained model for the user experience. So interactive exploration with ad hoc queries, detect fake news. Yeah, these are various examples with respect to the types of MLOps big data solutions. At the high level, the architecture design of big data ML operation solutions. Okay, so you're sourcing your data, your storage, your process, be it real-time processing or batch processing. You perform your analytical model building, which will serve your analysis for reporting or for building a model's predictive performance and making predictions or decision making for the user end. Right. So at a high level, your understanding with integration of big data with machine learning operations. Okay, so some components that we can come across with big data and MLOps, right? So data sources, we have various data sources. You have, as we discussed, docs, files, images, video. Then the topic we need to discuss is how to store all of these data sourced from various platforms, right? So storage is an important factor, whether you want to store the data in key value format or in a relational format, right? And some tools that we come across. Big data sources are from the web, cloud, media, documents, social influencers, databases. All these are various sources of collecting big data, right? And yes. Okay, so we spoke about batch processing, real-time processing. You can process your data in batches or in real time to improve the model's performance with continuous integration deployment. Few technologies that you want to think about while talking or applying real-time model building with machine learning and big data, right? So with MLOps and big data, so these are some of the tools that you can consider to integrate big data and MLOps. Apache Spark, MongoDB for storage of your database, Apache Spark for performing the transformation and engineering of your attributes through MapReduce, right? And yeah, so Hive and Apache HBase can be used for the model developed, which is being trained on the trained data, which can be used for production, right? So that model can be stored on Hive or HBase. Right. So these are your analytical reporting tools, and you can also perform analysis and perform queries or find insights from your data by using Tableau or Power BI or even Apache Uzi. So these are example tools that you can perform for use for analyzing and reporting, orchestration, and ETL. So at an overall view, what are the various roles and responsibilities for an engineer working with big data tools and ML operations? Ask yourself the various questions before you start diving into the application of building such large-scale complex models with machine learning and big data. I'm hoping you guys can take a minute to walk through the various questions that you need to ask yourself before you start working with big data and machine learning. Okay. Um, so we understand, what at a high level, what machine learning operations do with big data, right? Now, a case study is a popular case study of Netflix, right? And data content watched, the device on which the content was watched, what is the nature of the content watched based on varied based on the device, searches on the platform. So all these are different actions which have been applied on the interface, right? And based on the various actions done on the interface, the model takes into consideration on how to train its user experience and provide a better recommendation based on the previous search history, right? Or based on the previous experience of how the user interacts with the interface. So this is a case study of Netflix. So I'm sure you guys are aware that Netflix is a recommendation engine, which uses big data and machine learning analytical pipelines as the underlying architecture to provide rich experience for the users. Recommendation engine. So finally, what are the future of machine learning operations in software engineering? So MLOps solution provides data scientists with an easier and efficient way to maintain monitor models, right? By getting models into production and bridging the gap between the stakeholders teams, they can focus on data science with the help of MLOps. Deployment can be done on any platform, right? So this is the future. Future of software engineering is the ability to automate your machine learning models on the cloud, and so that the data which is processed in real time can also be engineered and scaled to the model, which is automated and continuously integrates and deploys it for production, and which will improve the overall performance of the model from time to time. Okay, so this is the reason why you should focus on learning the current market technologies, which is AI related subjects, big data and machine learning, deep learning. Okay, I hope this event was informative to any of you who are looking to transition your career into artificial intelligence or machine learning, and who are interested in data science, right? These are high level topics that you want to consider, which are really having an impact in the near future, right? The data is not going to reduce anytime. So the data is only going to linearly increase over time. And the ability to handle such high dimension data with big data tools and building automated pipelines for enriching the user experience. This event, I hope, is created some knowledge to all of you in for you to ever transition yourself from a non-technical field to a technical field. Thank you for joining the event. Have a great day.